In this video, we're going to work on the following problem. It says, if the cosecant of t is negative 7/3, find the other 5 trig functions of t, where t is in the fourth quadrant. Okay, so the first thing that we're going to do is just to draw a picture of the situation. So here we have the coordinate axes. We have an angle that's in standard position. So the vertex is at the origin, and the initial side points in the positive x direction. And then the terminal side would be down here in quadrant 4, right? So what that means is that the terminal side is going to intersect the unit circle right here at that point, down at some point down here in the fourth quadrant. And the main thing that we want to keep in mind is what are the signs of the coordinates of that point. And so that point is going to have down in the fourth quadrant is going to have a positive first coordinate and a negative second coordinate. Okay, and so so we're going to have to make some decisions later on about these things, and so it's good to keep that in mind. All right, so now I have the cosecant value, and so what I'm going to do is use one of the fundamental Pythagorean identities, in particular the one that involves the cosecant, right? And so that is going to be cotangent squared t plus 1 equals cosecant squared t. Okay, so that's the identity that I am going to use for this one here. So I will be able to figure out what the cosecant is. Okay, or I'll be able to figure out what the cotangent is, right? Because I know the cosecant, rather. Okay, so what I'm going to do is go and into the identity, and where there's the cosecant, I am going to substitute in negative 7/3, and remember it's cosecant squared, so that should be negative 7/3 squared. All right, and so when I do that, I'm going to get cotangent squared t plus 1 equals, and so I'm squaring a fraction here, squaring negative 7/3. So that is going to be the same as squaring the top and squaring the bottom. And so that's going to be negative 7 squared over 3 squared. And negative 7 squared is positive 49, right? That's negative 7 times negative 7. If hopefully you're not using your calculator to do that, but because it's pretty straightforward, but just if you are, then when you punch this into the calculator, you have to be careful. Don't plug it. You need to put parentheses around it like I have here. Otherwise, your calculator is going to give you negative 49, which is incorrect. Okay. Okay. So and then 3 squared is 9. All right, so now what I need to do is to solve for the cotangent squared part. All right, and I can do that by subtracting 1 from both sides. And when I do that, over on the left side, I'm just going to get cotangent squared t, right, because 1 minus 1 is 0. And then when I do 49/9 minus 1, remember I'm going to have to write 1 as a ninths, right? In other words, I'm going to have to get a common denominator because I'm subtracting, right, fractions. So I need to write 1 as some number over 9, and that number's got to be 9, right? Because 9 divided by 9 is 1. All right, and so now these two fractions have a common denominator, and so I just subtract the numerators. 49 minus 9 is going to be 40, and I keep it over the same denominator, 9. Okay. All right, and so now I have the cotangent squared isolated by itself on one side of the equation. So what I'm going to do is use the square root property, right? The square root property says if I have some quantity and it's squared and it's equal to some positive number, then there are two solutions, right? There is plus or minus the square root of the number over on the other side. So if cotangent squared is equal to 40/9, then the cotangent of t is either positive or negative square root 40/9. All right, so I'm going to have to choose one of those, right? I'm going to have to choose either the positive or the negative, right? And so that's where my diagram that I made at the beginning is going to come into play. So that diagram, I have to think about the definition of the cotangent. To find the cotangent of an angle, right, what you would do is take the first number, the x coordinate, and divide by the y coordinate, x over y, right? So the cotangent will be a positive number divided by a negative number. Well, a positive divided by a negative comes out to be a negative number. All right, so I know that the cotangent is going to be minus square root 40/9. I also need to simplify that as much as possible. Right? One of the rules about radicals in this class is don't leave fractions underneath the square root. And so cotangent t is equal to minus square root 40 over square root 9. And I can simplify that. The square root of 9 is just 3, right? So the bottom's going to become 3. I can also simplify this radical here. And so what I'm doing to simplify that is looking for the largest perfect square that will go into 40, and that's 4. Okay, so this is going to come out to be minus square root 4 times square root 10 over 3, and that's going to come out to be minus 2 square roots of 10 over 3. Okay. All right, so I found the cotangent. All right, so next up is we can do any of the others. We have cotangent and cosecant. So two of the ones that are pretty straightforward to find based off of that are the tangent itself. So let's do that one next. So to find the tangent, that's going to be 1 over the cotangent. It's also sine over cosine, but in this case, right, we know the cotangent. So this is going to be 1 over minus 2 square roots of 10 all over 3. All right, and so I'm dividing 1 by this fraction here, right? And so dividing by a fraction is the same as multiplying by the reciprocal. So 1 divided by minus 2 square roots of 10 over 3 is the same as 1 times 3 divided by minus 2 square roots of 10. Okay? And so I get minus 3 over 2 square roots of 10. I still have this radical in the bottom part of this fraction, right? So I need to rationalize it. So I guess I'll just get it down here to the next line. So I get minus 3, 2 square roots of 10. And to get rid of that square root of 10, all I would need to do here is multiply top and bottom by square root of 10, right? On the bottom, square root 10 times square root 10 is going to come out to be 10, so that will remove the radical there. And then to keep everything balanced out, I need to multiply the top by square root 10 as well. So get minus 3 square roots of 10. I have that 2 on the bottom, and then square root 10 times square root 10 is just 10, right? Because you would get square root of 100, which is 10. And so the final answer here is minus 3 square root 10 over 20 on that one. All right, another easy one is the sine. So let's go ahead and do that one right about here. The sine would be 1 over the cosecant. All right, because the cosecant, right, is 1 over sine. That means 1 over sine will, or 1 over the cosecant will be equal to the sine. Okay, and we know the cosecant is negative 7/3. And so I'm dividing 1 by negative 7/3. That's the same as multiplying 1 by negative 3/7. Okay, and any number times 1 is just itself. So we come up with negative 3/7 here. All right, so that leaves us with just cosine, right? We have, let's see. Yeah, cosine and secant are the last two that we need. Okay, so what we can do, right, is for cosine, we can use the fact that tangent is sine over cosine, or cotangent is cosine over sine, and use that because we know the tangent, the cotangent, and the sine. Right, we can figure out what the cosine is based on the identity. Okay, so let's go with just tangent again. So tangent of t, we know that that is sine over cosine. All right, we know the tangent, right, is minus 3 square roots of 10 over 20. And we know that the sine is negative 3/7, like so. Okay. All right, so then all we need to do is to solve this equation here. So the first thing that I would want to do here is, this has fractions in it, so normally what I would do is multiply through by the common denominator to get rid of the fractions, okay? And so normally what I would do is just multiply both sides by cosine first, so that's what I'm going to do. So over here, multiply minus 3 square roots of 10 over 20 times cosine t. And minus 3/7 over cosine t. Multiply that by cosine t as well. Okay, and the advantage that that has is that it gets the cosine out of the bottom over here on this side, right? Because I'm multiplying both sides by a cosine, I'll get rid of this cosine here. So I'll have minus 3/7 times cosine t. Oops, actually those will all go away. In other words, this cosine will cancel with this one right here. And I'll get, oops, I forgot to write the cosine there. Sorry, let me fix that really quickly. So this is cosine t here. And I have minus 3/7 over here. Okay. So now all I need to do to get the cosine by itself, right, it would be to multiply both sides of this equation by this thing flipped over. You can kind of think about that as dividing both sides. You could divide both sides by minus 3 square roots of 10 over 20, but then you would have to just flip it over and multiply anyway, right? So if you multiply, go ahead and just short circuit that by multiplying through by 20 over minus 3 root 10 and minus 3 root 10 over 20. So I'm multiplying over here. So let me make this a little smaller so you can kind of see where the flow is. I'm running out of room up here, so I'm going from here to here. Okay. All right, and then on the right side of that equation, I had a minus 3 root 7, and so I'd have 20 over minus 3 root 10. Okay, so these, right, since these are reciprocals, it's the same number but flipped over, right? All of this will multiply to 1. This 20 will cancel with this one. This minus 3 root 10 will cancel with this one. I'll just be left with cosine t here, which is what I want. Over on the right-hand side, right, I have a common factor of minus 3 here and 1 right here. And so those cancel out, and I get 27 square roots of 10. Like so. All right, almost done. The only problem is I have a square root in the bottom here, and so I need to rationalize by multiplying top and bottom by square root 10. So I get cosine t equals 20 square root 10. On the bottom, I'll have 7 times square root 10 times square root 10. Square root 10 times square root 10 is 10. All right, and so I'll wind up with cosine t, and here I have a common factor of 10, right? 10 goes into 10 once, it goes into 20 2 times. So I wind up with 2 square roots of 10 over 7 for the cosine. Okay. All right, so I'm kind of running out of room here, so I'm going to, let's see, what can I erase? I'll just go back up here to the beginning and do a little erasing. Not too much though, because we're almost done. Okay, so the last one is secant, right? That's the only one that we haven't done. And we know that's 1 over the cosine of t. Okay. And so we already know what cosine t, it's 2 square root 10 over 7, right? So we could just put 2 square roots of 10 over 7 here. But you can save yourself a tiny little bit of time, right, by using the unrationalized version right here. Okay. And so I'll show you. So you can use this one here, the simplified one, but we can also use this one up here, the one with the radical in the bottom. In this case, that's going to save us a little bit of work, right? And the reason why is because if I did 1 over 27 square roots of 10, right, then I am dividing 1, right, by this fraction right here. That's the same as multiplying by the reciprocal, right, of that fraction. So that would be 7 square roots of 10 over 20. And that's it. That's the answer on that one. So what would have happened had you used the other one, right? If we had used this version in the end, we would have had to end up rationalizing. But because we used this one, when we flipped it over, the radical was on top instead of being on the bottom, and that saved us a little work from doing that. It's just a little bit of work, but it's a little bit quicker that way. And one other place where we probably could have saved some time was using cosine. If we had used cosine or cotangent here, then the cosine would have been on top, right? And we would have had less algebra that we had to do. So I probably should have done it that way because it was actually simpler. But you could have done it either way. I just wasn't thinking, and I picked the wrong one that caused us to have to do a little bit of work on that one. right, and that is it on this one.